Well, 24 hours flies by. Actually, 48 hours at this point. The conference is coming towards a conclusion here. We've got about, T-minus 3 hours till the Exhibit 4 closes. I hope that each of you has found this useful and that you found it productive and worthwhile to your time, both those who are here as guests and those who are here as vendors and sponsors. I'm super excited about this last panel, and we're going to just jump right into it because I think we've got a full hour of content. So as we go through here, we've got 4 panelists here at the table. We've got a 5th that's going to join us remotely. Some faces you see are familiar that you saw this morning if you were here this morning. I'm going to go ahead and start off with one of our newest faces who is not here. Josh Brewer is the executive director for the Manhattan Area Habitat for Humanity, and that's Manhattan, Kansas. That's my hometown. And Josh and I have worked together for a couple of years now. I've served on the board. It's working on my 3rd year being on the board, and I'm currently the chair. Let me have Josh introduce himself and tell a little bit about Manhattan Area Habitat for Humanity.
My name is Josh Brewer. I am the executive director of the Manhattan Area Habitat for Humanity. We are an independent Habitat for Humanity affiliate that services 2 rural counties in northeastern Kansas. And our operations span construction repair, new construction, housing rehabilitation, and mortgage underwriting and mortgage servicing, so that we can create opportunities for home ownership for low income and workforce income category homebuyers.
All right, how many of you were not here this morning, just by show of hands? Okay, we got a few, so true. Dave, if you can introduce yourself again.
Okay, I think most of you have already heard this, but Dave Stevenson, I'm from Insulspan. We're a structural insulated panel manufacturing company. We have 2 manufacturing facilities, one in Michigan and another in Vancouver, British Columbia, just up the I-5 from here, which is where I'm from. I've been in the structural insulated panel industry for about almost 25 years now, and I am the sales rep for our Western division. But with my background in construction, I am also a site advisor for our company. And so I have just about as many years of experience with on-site SIP application installations.
All right, Jason.
Hi, Jason Carter with Bantam Global. We're a global housing solution that is entered the United States 4 months ago. We started out in a SIP panel solution. In the United States, we will be building volumetric 6-sided boxes. We've built about 3 million square feet in South America. Excited to be here. We are very focused on low carbon housing solutions.
And some of our new faces, we'll start off with Michael. Michael, tell us about yourself and who you're with.
I'm Michael Gibson. I'm an associate professor at Kansas State University and also a licensed architect. At Kansas State, I teach a studio called the Net Positive Studio, where master's students work on projects that they design, affordable net zero homes that they design and prefabricate. I do have a small residential practice that's kind of inching over into the prefab direction as well, but my research background is in building modeling and envelope design. So I didn't start with housing, but I'm from the Rust Belt. My family, a few generations back, was into fabrication, and so I developed a passion for the shop. So I kind of have my feet in 2 worlds.
Excellent. And Ted.
Hi, I'm Ted Clifton, designer and builder of net zero energy homes. We've been doing net zero homes in the Seattle area for about 12 years now, and building for just a little over 30. Got into doing SIPs about 20 years ago, and then slowly moved that into doing all electric, all net zero building.
So Ted is like this veteran in this space. I want to start off kind of our story today looking at what happened in Manhattan and what was put together, and I'm going to have Josh kind of tell it in his own words, but it was what we call the Workforce Solar Housing Partnership. And you're going to see a lot of logos here that a lot of partnerships are brought together. And why I think this is important for this audience is this is a group that in 2020 had not done building in this way and was able to accomplish it, which I think is very relevant for those of you. Most of you from this morning's session indicated you haven't really explored doing this before. So I'm hoping that this can be a starter of how can you just jump into this when perhaps you don't have any experience in it at all. So Josh, tell us about your story.
So our Habitat for Humanity affiliate historically has stick-framed, site-built houses, and has done so with the objective of delivering a product which is the most affordable housing product for minimum safety standards. And in the fall of 2020, following COVID disruptions to the supply chain, to the labor force, and to our investment stream through donations, we realized that we needed to go back to the drawing board and reimagine how we were delivering our housing type in our community. So we initially reached out to Kansas State University College of Architecture, Planning, and Design to help us rethink workforce housing. And what came out of that conversation was a fundamental shift in the process of delivering that housing type. And this is something that initially was a little difficult to wrap our head around. But with the capacity of the team at Kansas State University, we felt comfortable really jumping in and bringing along a partner at a local technical college, Manhattan area technical college, and an Army transition program called the Home Builders Institute for transitioning soldiers who are interested in the construction trades. And what this collaboration, which we've called the Workforce Solar Housing Partnership, imagined was a prefabrication approach that involved panelization prior to bringing panels to the construction site for assembly on site. And initially, we looked at some options for sandwich SIPs, but felt like for local building codes and inspectors, and for the acceptance from the local building community, we would need to incorporate studs into our structure. So we found a panel manufacturer in Idaho named Raycor that manufactured those stud panels. So a little different than a traditional SIP panel, and we brought those to the site at AP Design at Kansas State University, and then that team fabricated the units to be assembled on site from the panels. So the process had shifted, and then the other piece that the AP Design team, along with another nonprofit in the community called the Flint Hills Renewable Efficiency and Renewable Energy and Efficiency Cooperative, brought to the table was a commitment to developing net zero, or what they called net positive solutions. And so what we looked at along with Michael Gibson's studio team is how we could design the structure to have better thermal performance and better air tightness, so that we could create affordability by downsizing the mechanicals and by reducing the homeowner's cost of operating the home. Those cost savings allowed us also to install a solar photovoltaic array on the structure, which further reduces the cost of operations for the structure. Now, Kansas net metering requirements are not advantageous for producing energy. And so we, because we had energy modeling on the site, we were able to right size that array to maximize the the value for the homeowner, who ultimately takes out a mortgage that we originate and finance on the home. And so the bringing on the AP design team allowed us to put something to pilot a process that's not seen in our market currently, a prefabrication and modularized, a panelized process that we have not seen locally, and which historically, when brought up, the building community did not feel would be appropriate to our community, or in many cases even possible in the community. And so this has allowed us to bring local architects and local builders to our build site after construction, and to involve the local subcontracting community, electricians who had some pretty serious concerns about how they could work in a structure that had panels, and HVAC professionals who had some questions about the performance of heat pump technology and the sizing of the heat pumps in a structure like this, all the way back to the concrete professionals who had not seen our slab detail, a high performance, a frost free, shallow slab type in residential construction. And so by being able to pilot this sort of innovative housing product in our local market, we've begun the process, hopefully, of normalizing performance construction in the low to moderate income affordability space.
Yeah, a little bit long, but I think good foundation to start with. So thoughts, reactions so far from those of you who haven't heard this story before, and then we'll have kind of Michael add his 2 cents, having been involved in it.
I mean, I agree with him in that, what we've found is our key in marketing is letting people know how much they're saving in utility bills by taking that extra step to make a super insulated and efficient structure. And so far, we found the payback for what we're doing all electric net zero energy houses. The payback's about 12 to 18 years for each individual technology. And if you're on a 30-year mortgage, that means your bills are less every month. So it's actually cheaper to get to that net zero goal than it is to build the code minimum. So once people understand that, then you're like, okay, well then what's the cheapest way to get to net zero? It becomes your main goal.
That's a good selling point. Other thoughts?
No, I would agree. I think that, we're here mainly talking about, prefabricated systems. There's different types of panels which they've used, but the prefabricated panels are really only one part of an entire whole house solution, with mechanical systems and everything else that's incorporated. So it's not one thing or the other. It's more and more all of these different technologies combined for the.
Well, and once net zero gets to be the goal, you start to look at what kind of wall and roof details you need to get there. And if you look at the architect's ideal wall and some of these assemblies, you look at and you think, wow, that is really complicated. And some of them are incredibly complicated with 6 different layers of parts. And with a SIPS wall detail or a SIPS roof detail, it's the simplest thing you've ever seen. It's super easy to assemble. It's just, you just put that on, and that's all your framing, your insulation, your air sealing is all kind of done all in one really fast setup.
So Michael, you want to tell us a bit about what we're seeing here?
Sure. So, and I think something to emphasize with what Josh said was that we're working with learners. So they're working learners, and I'm excited to be on the educational side of this because I think it's something it's just going to keep gaining traction. So this is the way that we produce our panels in the shop, and these are actually Masters of Architecture students. They're not they're not construction students, but they design the house. They develop a fabrication drawing set in addition to their CD set, and they put it together, and it goes out on the site. And so far everything fits together. It's kind of a magical thing to see those pieces come together. People are really surprised if they don't know much about prefab. How quickly the shell goes up. And actually one of the things that happened in Ogden, Kansas, when we were building the build 2 years ago was a bunch of school kids walked by the site in the morning.
This is the house you're talking about.
Yeah, they walked by the site in the morning, and then at the end of the day, the walls were up, and we were starting to work on the ridge beam and stuff. And they're like, "Whoa! Like, where'd this house come from?" So these are small houses. I think some of the design points, the value of design is we right size the house. So these are our houses are typically under 1,200 square feet. That allows you to make a really robust envelope, invest in systems and finishes, and make it a space that feels big, even if the floor area is not very large. So how many people in here are architects? How many people work with architects on a regular basis? Okay, so some of you do, but I think this is, I'm an architect, maybe I'm biased, but I think the work of the students in this process of designing the thing to be right in the first place, to do, we all know this about sustainability, that you need to start at the beginning. It's a process of integration and collaboration. And we model that in the studio, starting with good design.
I like that you're teaching them production drawings.
Yeah.
I'm a factory guy, so most architects don't understand how to do production drawings. And in factory setting, you got to understand how all that works. You got to have
Absolutely.
the details. That's great.
Some things to kind of point out, if you can see here in the photos, particularly in the entrance room as you come in, you can see it's got the high vaulted ceilings because you've just got panels up at the top. You can see the HVAC tube running through there, which is simple but effective, and really accomplishes those goals. This is another prototype you did. You want to tell briefly about this one?
This project actually was part of the Department of Energy's Solar Decathlon, if anyone is familiar with that. And this is in a very rural place, St. John, Kansas. It's a town that has about 900 people in it. And you can see the solar array in this photo. Due to the size of the house, I think Kansas is a great climate to do passive first, design for load reduction. If you do this right in Kansas, you're going to save the time you're actually going to rely on your HVAC systems is only going to be about 60 or 40% of the year. So to get to net zero, it only takes 12 380 watt modules. So very inexpensive system. This house also has a porch. Some of the basic design ideas are to make this connection to the outside to get people actually going outside. And I think something we're starting to talk about a lot more is user education, getting people to sort of commit to the energy-saving behaviors in the house. I know this is a structures and systems panel, but that's, you really have to do that to make that work, to sort of teach people how to use the house.